Now we are going to see some additional properties of exponentiation that may be obvious, but anyway, first observation. Exponentiation with base 1 always equals 1. It doesn't matter whether the power is positive, 0 or negative. If positive, the exponentiation is just some factors of 1, which is 1. If 0, well, by definition, anything to the 0 is 1. And if negative, the expression is just reciprocals of multiplications of 1s. 1. Second observation. In this case, if the power is positive, 0 to the n is just multiplications of zeros, hence equals 0. But if the power is 0, that means we have 0 to the 0 is equal to 1. Lastly, if the power is negative, so we have 1 over 0 to some positive power, we have division by 0, which is undefined. Thus, we have 3 different results for 3 different situations. Third observation. Now, what if we have negative powers on a denominator? Well, just use the definition of negative power on the exponentiation, and using a rule of fractions, we can simplify the whole expression to this. So we can turn negative powers on the denominator to positive powers on the numerator. Fourth observation. There are 2 things about this equation. 1. A, the results of taking a square is never negative, no matter which whole number we input into x. If x is positive or negative like this, the squares will both be positive. And if x is 0, 0 square is 0. The second thing is that if x is unknown and we have positive a, let's say 4, then there are 2 possible solutions for x. The most obvious one is of course 2. 2 squared is 4. But the less obvious answer would be minus 2. See, minus 2 squared is also 4. You may guess that the 2 solutions for x is always a positive and negative pair. And you'd be right. Now actually, this fourth observation also works for exponentiation of any even power, like 4, 6, etc. You may check it by yourself. Well, that's enough for now. Thank you very much for watching.